Welcome to Channel Cosmic Lullaby Channel. In the corridors of power, in the digital battlegrounds of the 21st century, a silent war is being waged. It is a conflict fought not with armies or currencies, but with something far more fundamental. It is a race to master a force that dictates the flow of information, the balance of economic power, and the very structure of our reality. This is not the story of matter or territory. It is the story of light. Tonight, we pull back the curtain on the most powerful, enigmatic, and weaponized element in the universe. It is a force made of no substance we can measure, yet it carries pure, raw energy across the desolate vacuum of space. It moves with a terrifying and absolute precision, a speed that never changes, a cosmic law that cannot be appealed, no matter who is watching or how fast they are moving. Every stock market transaction that flashes across the globe, every encrypted military communication, every strategic satellite image of a rival nation's assets, every single piece of our modern world begins and ends with the properties of light. It is both our most critical messenger and our ultimate unyielding measure. Through it, we have learned not only how the universe behaves, but how to bend its rules to our will, to build empires of data, to project power, and to gain an edge in a world where a nanosecond can mean the difference between victory and defeat. This is not a gentle lullaby about the stars. This is an intelligence briefing on the fundamental force that will define our future. The story begins with a paradox so profound it nearly broke physics. For a century, we have known that light exists as two things at once, a wave and a particle. It is a dual identity that defies all classical intuition and challenges the very bedrock of what we consider real. In some contexts, it moves like a ripple spreading through a pond, an expanding wave of energy that can bend, spread, and overlap to create intricate patterns that only waves can produce. This is the light of fiber optics, the lifeblood of global finance and communication, a wave guided through glass tunnels spanning entire oceans. But in other contexts, when it strikes, it behaves as a particle, an individual packet of focused energy arriving one at a time, a discrete quantum of energy we call a photon. This is the light of solar panels powering off-grid military installations, the light of lasers guiding munitions with pinpoint accuracy. Both descriptions are correct, yet they are mutually exclusive in our everyday world. Light's identity, its very nature, shifts depending on how it is being used, how it is being observed. This strange duality is not some esoteric quirk. It is the operational principle of the quantum age. From the quantum computing race, where nations vie to build machines that can shatter any known encryption, to the development of next-generation sensors that can detect a single photon, our mastery of this paradox is a direct measure of our technological supremacy. The quantum world reveals that reality is not a fixed, deterministic machine, but a landscape of probabilities, a system that unfolds differently depending on how we choose to look at it. And in a world of surveillance and counter-surveillance, knowing how to look is everything. The spectrum of light, once a painter's palette, is now a strategic map. Every color we perceive is simply a different frequency of the same fundamental energy. Red light vibrates at a slower, longer wavelength, while violet light vibrates with a faster, higher energy. Our eyes evolved to see only a tiny sliver of this range, the so-called visible spectrum, because it's the most abundant frequency range in the sunlight that reaches Earth's surface. But the true battle is fought in the colors we cannot see, Beyond the red lies infrared, the light of heat signatures, which allows a predator drone to track a target in total darkness. Beyond violet lies ultraviolet, carrying enough energy to sterilize equipment, but also to serve as a covert signaling channel visible to specialized sensors. The full electromagnetic spectrum extends from radio waves miles long to gamma rays, smaller than an atom. Each band is a domain, a theater of operations for communication, espionage, and warfare. Radio waves carry our broadcasts and commands. Microwaves power radar systems that guard our skies. X-rays see through solid objects, revolutionizing both medicine and security. And gamma rays, the most energetic light of all, are the signature of nuclear events. Every wavelength is part of the same unbroken field of light, a continuous strategic asset waiting to be exploited. The story of that light, the energy we depend on for everything, begins not here on Earth, but inside a star 93 million miles away. The sunlight that warms your face today began its journey just over 8 minutes ago, racing through the void at the fastest speed nature allows. But the photon itself is ancient. Deep within the sun's core, under unimaginable pressure, hydrogen atoms are crushed together to form helium, releasing colossal amounts of energy in the process. A photon born in that nuclear furnace does not escape easily. It is absorbed and re-emitted countless times, staggering through dense layers of plasma in a journey that can take hundreds of thousands of years. When it finally breaks free from the surface, it streams into space. The energy that left the solar surface just minutes ago was actually created before the dawn of human civilization. It is a reminder that the forces we harness are ancient, powerful, and utterly indifferent. They set the rules. Our only choice is how we play the game. When we look up at the stars, we are not seeing space as it is now. We are looking at a historical record. The light from even the nearest stars began its journey trillions of miles away, years or even centuries in the past. That faint glow is a snapshot, an intelligence file carrying data from a bygone era. Our most powerful telescopes are, in effect, time machines. They gather this ancient light, allowing us to witness events that occurred long before our own world took shape. When strategic analysts study the color and brightness of that starlight, they can deduce the composition, temperature, and motion of celestial bodies, revealing the cosmic evolution of stars and galaxies. The night sky is not a static portrait. It is the ultimate passive surveillance system, a window into deep history, where every photon is a piece of evidence. But this principle has a terrifying modern implication. The universe is governed by a single, unbreakable law. Nothing, absolutely nothing, can travel faster than light in a vacuum. This is not a technological barrier we can one day overcome. It is the fundamental operating system of reality itself. Every financial transaction, every military command, every transfer of data must obey this absolute speed limit. In the world of high-frequency trading, where algorithms execute millions of trades per second, this cosmic law is a tangible and ruthless barrier. The difference of a few milliseconds in the travel time of light through transatlantic fiber optic cables can mean the gain or loss of billions of dollars. Corporations spend fortunes to lay cables in straighter lines to shave microseconds off the journey, because in their world, the speed of light is the ultimate currency. In geopolitics, this limit defines the horizon of command and control. A signal from Earth takes over a second to reach the moon, 8 minutes to reach the sun, and hours to reach our robotic probes in the outer solar system. For a commander controlling a drone on the other side of the world, the latency, the time it takes for light to carry the signal there and back, is a life or death variable. The constancy of this speed, regardless of the observer's motion, is what led Albert Einstein to dismantle our understanding of the universe and forge the theory of relativity, forever binding space and time into a single unified fabric. Light is not just the fastest thing in the universe, it is the standard by which all motion, all cause and effect are measured and constrained. This is not abstract theory. It is embedded in the most critical military and civilian infrastructure on the planet, the Global Positioning System, or GPS. The satellites that provide our location data are moving at immense speeds and are in a weaker gravitational field than we are on the surface. According to relativity, their clocks should tick at a different rate than ours. Without constant, precise corrections based on Einstein's equations, the entire GPS network would accumulate errors so rapidly that it would become useless within minutes. Navigation systems would fail, supply chains would collapse, and crucially, precision-guided weapons would lose their targets. Every drone strike, every smart bomb, every naval fleet navigating the globe is utterly dependent on a theory born from the immutable speed of light. Yet, while its speed in a vacuum is absolute, the story changes when light passes through a medium. In glass, water, or even air, its progress is slowed. Photons are absorbed and re-emitted by atoms, creating a delay in their journey. This effect is the basis for all lenses, for the fiber optic cables that form the backbone of our civilization. But in the world's most advanced laboratories, a new race is underway. Scientists have pushed this principle to its absolute extreme. Using ultra-cold clouds of atoms, little more than a whisper above absolute zero, physicists have slowed light from 186,000 miles per second to the speed of a bicycle. They have even stopped it entirely, storing its energy and its information within the atoms themselves, only to release it later perfectly unchanged. This is not a parlor trick. This is the dawn of a new technological revolution. To stop light is to control information at its most fundamental level. These experiments are the foundation for technologies that were once pure science fiction: quantum memory systems, unhackable communication networks, and processors that compute with light itself. The nation that perfects the ability to store and retrieve quantum information encoded in light will hold an insurmountable strategic advantage. It could render all existing encryption obsolete, create sensors of unimaginable sensitivity, and build a communication network that is physically impossible to intercept without being detected. The race to control the speed of light is a silent arms race, a battle for the future of information itself. For humanity, the visible world has always been the only world. Our senses, our societies, and our strategies have been built on a laughably narrow slice of reality. But the 21st century battlefield is no longer confined to what the human eye can see. A silent, invisible war is being fought in the vast territories of the electromagnetic spectrum that lie beyond our biological limits. And in this domain, we are naturally blind. Our eyes can only perceive the thin band of light that runs from red to violet, a limitation that hostile actors and strategic competitors are now ruthlessly exploiting. Beyond our perception lies an invisible universe of light, a landscape rich with tactical data. Infrared radiation, which we can only feel as warmth, becomes the ghostly signature of life and activity in the dark. It reveals the heat from a hidden convoy of trucks, the thermal plume of a submarine just below the surface, or the residual warmth of an aircraft that has recently departed its hangar. Ultraviolet, a wavelength invisible to us, carries signals and reveals materials that are otherwise hidden. In this unseen world, our biological limitations have become a critical vulnerability. But where human evolution stopped, human ingenuity has taken over. We have built cameras and sensors that extend our vision far beyond our natural capabilities, weaponizing the invisible world. Through these instruments, we can now observe the heat signature of an adversary's industrial output, using thermal imaging to gauge economic activity from orbit. We can map the spectral fingerprints of exhaust plumes to identify the type of fuel a missile uses. We have, in effect, weaponized the entire spectrum. This technological arms race is a frantic effort to overcome a sensory deficit that other creatures on this planet never had. For millions of years, nature has been perfecting sensor technology in this hidden world. Bees navigate using ultraviolet patterns on flowers, which act as sophisticated landing guides, a natural form of target acquisition that our own smart munitions are still trying to master. Certain snakes have evolved to see the infrared glow of their prey, allowing them to hunt with lethal precision in what we would consider total darkness. They possess a biological forward-looking infrared FLIR system that is the envy of our most advanced defense contractors. These are not just biological curiosities, they are proof of concept, demonstrations of what is physically possible. The field of biomimicry now looks to these animals not for inspiration, but for blueprints. How can we replicate the snake's thermal sensitivity to build better night vision systems for our soldiers? How can we copy the bee's UV navigation to create autonomous drones that can operate in GPS-denied environments? Every advantage in nature is a potential technological advantage in war. Our dominance now depends on our ability to see what is deliberately being hidden. But for every sensor, there is a countersensor. For every new way of seeing, there is a new way of hiding. The development of multispectral camouflage, stealth coatings that absorb radar, and cooling systems designed to minimize thermal signatures is a direct response to this new era of hyperspectral surveillance. It is a perpetual cat-and-mouse game fought in wavelengths of light, where the prize is invisibility. The ultimate power is not just to see the enemy, but to remain unseen yourself. To operate freely in a domain your adversary cannot even perceive. This brings us to the most ancient light of all, a signal that has been traveling since the dawn of time itself. Long ago, when the universe was in its infancy, it was a searing, opaque fog of charged particles that trapped all light. But as the cosmos expanded and cooled, a pivotal moment occurred. The particles combined into neutral atoms, and for the very first time, light was set free. That primordial flash, the afterglow of creation, still fills all of space today. It is known as the cosmic microwave background. It is the oldest, most distant signal we have ever detected, a faint, cold whisper from the very beginning. By studying its faint temperature variations, we have learned the age, composition, and ultimate fate of our universe. But this ancient light also teaches us a crucial lesson, that even the most impenetrable fog will eventually clear. For strategists, the question is, what will be revealed when it does? What secrets, what capabilities, what threats are currently hidden from us, waiting for the moment when our vision finally becomes sharp enough to see them? The universe has been sending us messages for 13.8 billion years. We are only now beginning to learn the language. Every day, the Earth's atmosphere conducts a massive experiment in information filtering. The familiar color of our sky and the fiery red of a sunset are not accidents of nature. They are the result of a physical process with profound strategic consequences. When sunlight, a full spectrum of information, enters our atmosphere, it collides with a dense field of air molecules. This collision course forces a choice. Shorter wavelengths of light, the blues and violets, are scattered violently in all directions, creating the blue dome we see above us. But the longer wavelengths, the reds, oranges, and golds, are more resilient. They punch through the atmospheric interference with greater ease. As evening approaches, the sun's light is forced to travel through a much thicker slice of this turbulent medium to reach our eyes. By the time it arrives, most of the blue and violet light has been scattered away, filtered out of the signal, leaving behind only the resilient, long wavelength hues of red and orange. This isn't just poetry, it's a daily lesson in signal degradation. For any nation relying on space-based surveillance, the atmosphere is not an empty void, but a hostile, distorting lens. Every spy satellite, every reconnaissance drone must contend with this same scattering effect. The very process that paints our sunsets can blur a critical target, obscure troop movements, or render high-resolution imagery useless. Sophisticated algorithms now work constantly to correct for this atmospheric distortion, digitally subtracting the haze and interference to reconstruct a true picture of the ground. But the filters are not perfect. Atmospheric conditions, such as dust, pollution, or water vapor, can dramatically enhance this scattering effect, creating a natural smokescreen that can blind even our most advanced orbital assets. A strategically timed industrial burn, or the smoke from a large wildfire, can provide temporary but critical cover from overhead surveillance. Understanding and predicting these atmospheric optical conditions has become a critical part of modern intelligence and military planning. It is a battle of physics, where the goal is to see clearly while your adversary cannot. But the atmosphere is also a stage for events of far greater violence, where light is forged in an instant of unimaginable power. During a thunderstorm, the air itself becomes a weapon. Electrical charges build between clouds and the ground until the tension is unbearable. The result is a catastrophic failure of insulation, a lightning strike. In that single moment, a channel of air is heated to tens of thousands of degrees, a temperature hotter than the surface of the sun. The surrounding gas is instantaneously transformed into a luminous state of matter known as plasma, exploding in a brilliant white flash that contains nearly every color of visible light. The shock wave from this rapid expansion is what we hear as thunder. But the true strategic importance of lightning is not its light or sound. It is the colossal electromagnetic pulse, an EMP, it generates. A single powerful bolt can induce crippling power surges in electrical grids, fry sensitive microelectronics, and disrupt communication networks over a wide area. While a natural lightning strike is unpredictable, it serves as a terrifying model for a new class of weaponry. For decades, military planners have studied the devastating effects of a high-altitude nuclear detonation, which would generate an EMP powerful enough to cripple an entire continent, sending its technological infrastructure back to the 19th century. But lightning is nature's own EMP weapon, and its power is not just destructive, it is also creative. Each brilliant flash triggers complex chemical reactions in the atmosphere, forming nitrogen compounds that are then carried to the Earth by rain, acting as a natural fertilizer. This intricate dance of destruction and creation is a stark reminder that the most powerful forces on this planet are not man-made. They are fundamental principles of physics that we are only beginning to understand and attempting to control. In laboratories around the world, research into directed energy and plasma physics continues, driven by the ultimate goal of harnessing and directing this same elemental power. To master lightning is to master the ultimate high-energy weapon, a force that can be deployed at the speed of light to neutralize any electronic target. In the natural world, communication is a matter of survival, and the most effective signals are the ones that are only visible to the intended recipient. For millions of years, a silent, encrypted conversation has been taking place in wavelengths we cannot see. Many flowers, which appear to us as simple fields of color, are in fact broadcasting highly sophisticated targeting data. They are covered in intricate ultraviolet patterns, invisible runways that guide their primary partners, bees, directly to their core. This is not a random aesthetic. It is a co-evolved system of breathtaking precision, a secure communication channel designed to minimize interference and maximize efficiency. The flower broadcasts a signal, and the bee possesses the unique sensor required to decode it. To every other creature, the signal is just noise, the flower just a color. This is nature's own Identify Friend or Foe, or IFF system, a visual password written in a wavelength of light that is inaccessible to most predators and competitors. This biological reality is the blueprint for a new generation of military and intelligence technology. The goal is to create covert communication and targeting systems that operate on channels an adversary is blind to. Imagine soldiers wearing uniforms with markings that are invisible in the visible spectrum but glow brightly for specialized night vision goggles, allowing them to instantly identify friend from foe in the chaos of battle. Consider targeting pods that illuminate an objective with a laser designator in a unique, non-visible wavelength, ensuring that only a specific munition with a matching sensor can lock onto it. The natural world has proven that the most secure channel is the one your enemy does not even know exists. The overall challenge in signals intelligence is therefore twofold: to develop our own covert channels and to build the next generation of hyperspectral sensors capable of detecting an adversary's hidden light, of seeing the secret patterns they believe are perfectly concealed. It is a perpetual struggle to master the art of the invisible signal. But light does not just carry hidden information. Its path can be deliberately bent and distorted, turning clarity into confusion. When light passes from one medium to another, from air into water for instance, it changes speed and direction. This bending, known as refraction, is responsible for the simple illusion of a straw appearing kinked in a glass. But in the theater of war, this is no illusion. It is a critical and dangerous variable. For a naval helicopter hunting for a submarine or an unmanned underwater vehicle searching for sea mines, refraction is a constant adversary. It warps the apparent position and depth of a target, making a direct hit a complex problem of physics and calculation. The ocean's surface acts as a distorting lens, a natural instrument of deception that can mean the difference between a successful mission and a catastrophic failure. What the eye sees is a lie, a ghost image displaced by the bending of light. Anti-submarine warfare and mine-clearing operations invest heavily in sophisticated sonar and optical systems designed to correct for this very distortion. Yet, the same principle that creates deception is also the foundation of all optical power. Every lens in every pair of glasses, every camera, every microscope, and, crucially, every telescopic sight on a sniper's rifle or targeting system on a satellite operates on the principle of refraction. Our ability to see across vast distances, to magnify the microscopic, and to guide weapons with pinpoint accuracy comes from our mastery over bending light. The precisely ground lenses in a spy satellite's camera are designed to gather and focus faint rays of light that have traveled hundreds of miles through a turbulent atmosphere, correcting for distortion to deliver a clear image. The lenses in a laser-guided missile seeker head are engineered to see and lock on to a single designated point of light. To control refraction is to control sight itself. It is the power to overcome illusion and to project vision far beyond its natural limits. This fundamental principle of light is even responsible for one of nature's most beautiful displays, a phenomenon that is, for an intelligence analyst, a perfect lesson in perspective. A rainbow is not an object. It is an effect, a circle of light that is unique to every single observer. While it appears as an arch in the sky, it is in fact a full circle whose lower half is usually blocked by the horizon. Each droplet of rain acts as a tiny prism, bending sunlight, splitting it into its constituent colors and reflecting it back at a precise angle. But because the geometry depends on the exact position of the observer relative to the sun and the rain, no two people, no two sensors can ever see the exact same rainbow. It is a personal alignment of source, medium, and detector. This is a fundamental truth of intelligence gathering. What you see depends entirely on where you are looking from. A satellite in one orbit will see an event differently than a satellite in another. An agent on the ground provides a perspective that a drone overhead cannot. The overall picture, the full circle of truth, can only be assembled by combining these unique individual viewpoints, understanding that each one is just a single arc of a much larger reality. In the world of intelligence, the greatest challenge is not the absence of information, but the overwhelming flood of it. A storm of raw, unstructured data pours in every second from every corner of the globe. To the untrained eye, it is chaos. But nature provides a powerful model for how to find order in that chaos. When sunlight, a uniform torrent of white light, passes through a rainstorm, it is subjected to a vast, coordinated analysis. Each individual raindrop acts as a tiny, perfect prism. It intercepts the incoming light, slows it, bends it, and forces it to reveal its hidden components. The result is that a single monolithic beam of sunlight is deconstructed into a spectrum of individual colors. The arch that appears in the sky is not a single object. It is the combined output of uncountable droplets, each contributing a single narrow beam of colored light to a specific viewpoint. This is the exact principle behind modern signals intelligence and big data analysis. A massive, undifferentiated stream of data, global internet traffic, satellite radio signals, financial transactions, is the equivalent of the white sunlight. The analytical tools, the algorithms, and supercomputers are the raindrops. They are designed to intercept the data stream and break it down, searching for specific signatures, for hidden patterns, for the individual colors of information that are otherwise lost in the glare of the whole. A single analyst, a single sensor, may only provide one small piece of the puzzle, a single point of colored light. But when the output of a distributed network of thousands of these sensors is combined, a clear and coherent picture, a rainbow of intelligence, emerges from the noise. Every major intelligence agency now operates on this principle. The overall mood of global data is to become a predictable, analyzable spectrum of information, revealing the underlying structure of an adversary's communications, economy, and strategic intentions. The very concept of white light itself is a powerful metaphor for modern encryption and data concealment. To our senses, white light appears to be the absence of color, a neutral, basic state. But this is a profound deception. It is, in fact, a perfectly balanced presence of all visible colors, a harmonious chord of many different frequencies resonating together. A simple prism reveals this truth instantly, separating the blend into its constituent parts. In the same way, a heavily encrypted data stream is designed to look like nothing. It is engineered to mimic the statistical properties of random, meaningless noise. It is, for all intents and purposes, digital white light. But to the agency that holds the correct cryptographic key, the digital prism, that stream of noise can be instantly resolved into its component parts: voice communications, video feeds, financial data, and military commands. The ongoing war in cyberspace is a battle of prisms. It is a race to build encryption that can create a perfect, unbreakable white light, and to develop analytical tools that can crack an opponent's signal and see the hidden colors within. This is why astronomers analyze the light from a distant star. Its seemingly white glow, when passed through a spectrograph, reveals a complex series of dark and bright lines, a spectral barcode that exposes the star's chemical composition, temperature, and motion. The same technique is used to analyze the plume of a missile test or the output from a factory smokestack. The light itself carries the secret intelligence, waiting for the right tool to decode it. This brings us to one of the most critical and contested technologies of our time, the creation of artificial crystals. In nature, minerals can slow and split light in fascinating ways. But in the laboratories of defense contractors and technology giants, this process has been perfected. Scientists now grow ultra-pure, engineered crystals with atomic structures designed for one purpose: to control light with absolute precision. These are not gemstones, they are the strategic components that underpin our entire technological world. In some of these materials, the internal atomic lattice creates two distinct paths for light, each with a different speed, effectively splitting a single laser beam into two. This property is essential for the high-speed optical switches that direct traffic in our data centers and undersea cables. The global economy runs on light guided through these crystalline gateways. The nation that dominates the design and fabrication of these photonic crystals controls a fundamental choke point in the flow of global information. These same crystals are the heart of modern laser weapon systems. By guiding powerful beams of light, they allow for the targeting and destruction of drones, missiles, and mortars at a cost far lower than traditional interceptors. The beauty and precision of a crystal have been weaponized, turning a scientific curiosity into a cornerstone of 21st century defense. From global finance to the battlefield, power now flows along ordered pathways carved through a new kind of manufactured stone. In the deepest trenches of the ocean, sunlight is a forgotten memory. It is a realm of absolute blackness, crushing pressure, and cold, the perfect environment for stealth. Yet it is not truly dark. In this eternal night, life has engineered its own solutions for illumination, communication, and warfare. This is the world of bioluminescence, where living organisms create their own light through highly efficient chemical reactions. Anglerfish deploy glowing lures, biological decoys, to attract their prey in the darkness. Jellyfish pulse with soft, ethereal halos, a visual alarm system designed to startle predators. And certain shrimp, when cornered, eject sparkling clouds of luminous fluid, a living smokescreen to cover their escape. This is not nature's art. This is nature's art of war. Every flash and glow is a carefully evolved tactic for hunting, signaling, camouflaging, and surviving in a high-stakes environment where light discipline is paramount. For military strategists, the deep sea is a living laboratory for next-generation technology. The chemical process these creatures use, converting stored energy into light with almost no heat, is the holy grail of covert operations. This is cold light. A conventional light source is a beacon for any thermal imaging system, a fatal giveaway on a modern battlefield. But a bioluminescent signal is, by its very nature, thermally invisible. It is a ghost in the machine. Defense research agencies are now pouring resources into mimicking these biological reactions to create markers, signals, and illumination sources that are undetectable by infrared sensors. Imagine a special operations team marking a target for extraction with a substance that glows faintly in the visible spectrum but is completely cold. Or a downed pilot whose survival vest is coated in a material that pulses with a specific bioluminescent signature visible only to friendly rescue assets. The chemistry of the firefly, long a symbol of summer nights, is now a subject of intense military interest. Its light, produced by the reaction between luciferin and oxygen, is one of the most efficient light sources known to exist, wasting almost no energy as heat. The overall mood of biological light, however, pales in comparison to humanity's greatest achievement in the control of photons. From the scattered, organic light of the deep sea, we now turn to the ultimate expression of order and power, the laser. Ordinary light is a chaotic mob of waves moving in countless directions and frequencies. Laser light is a disciplined army. Inside a laser, a specialized material, a crystal, gas, or semiconductor, is energized, priming its atoms for a specific task. When a single photon of the right frequency passes by, it stimulates its neighbors to emit identical photons, all moving in the same direction with the same frequency and phase. Mirrors at each end of the device reflect this growing beam back and forth, building a cascade of perfect, synchronized copies until an intensely focused, coherent stream of light. The very name, laser, is an acronym for this process: light amplification by stimulated emission of radiation. It is a precise and elegant description of a profound physical process, a process that turns chaos into a weapon. The destructive potential of this technology is matched only by its utility. The same coherent light that powers the global internet by flashing through fiber optic cables can be scaled up to create a beam that cuts through steel. The same precision that allows a surgeon to reshape a human cornea can be used to blind the optical sensors of an enemy satellite in orbit. The overall mood to this point began not with a weapon, but with a crystal. The first working laser, built in 1960, used a synthetic ruby rod, energized by a bright flash lamp. That first slim beam of deep red light was a turning point in human history. It was the moment we transitioned from being passive observers of light to active commanders of its power. That single ruby-red spark was the dawn of the directed energy arms race, a competition that continues to this day in secret laboratories, a contest to forge the ultimate sword of pure light. The power to project energy across continents is a blunt instrument. The true frontier of 21st century power lies in precision. It is the ability to control not armies, but atoms. In the world's most advanced laboratories, a technology of almost unimaginable delicacy is now a routine tool. A tightly focused laser beam can act as a set of invisible fingers, holding a single microscopic particle steady in space. These optical tweezers create a tiny prison of light, a force field that can trap and manipulate a living cell, a strand of DNA, or a custom-engineered nanoparticle. By simply moving the laser's focus, scientists can steer these objects with a precision that was once the domain of science fiction. On the surface, this technology has revolutionized biology, allowing researchers to measure the forces inside living cells and understand the mechanics of disease. But its strategic implications are far more profound. The ability to manipulate matter at the microscopic level is a foundational technology. The overall mood is not just a form of engineering, to building materials and machines from the atom up. The nation that masters this on an industrial scale could create self-repairing alloys, biological sensors that patrol the bloodstream, or micro-drones the size of a dust mote. The gentle force of optical tweezers is a precursor to a new kind of manufacturing, a new class of weaponry, and a new understanding of life itself. It demonstrates a fundamental principle. Light is not just a form of energy to be observed. It is a physical tool that can exert force, a lever that can move the building blocks of our world. But even more powerful than the ability to move matter is the ability to identify it from a distance. And for that, we turn once again to the language of light. Every atom in the universe has a secret identity, a unique and unforgeable signature that it broadcasts to the cosmos. This signature is revealed when an atom interacts with light. Its electrons can only exist in specific, discrete energy levels. When a photon with the exact right amount of energy arrives, an electron will absorb it and leap to a higher level. It cannot stay there for long. It soon drops back down, emitting a new photon of a precise color, a specific wavelength that corresponds exactly to the energy gap it just crossed. Each element, hydrogen, helium, uranium, plutonium, has its own unique set of these energy gaps. As a result, each element has a unique spectral fingerprint. When the light from a source is broken down by a prism or a spectrograph, this fingerprint appears as a pattern of bright and dark lines, a cosmic barcode. This is the science of spectroscopy, and it is the single most powerful tool of remote intelligence gathering ever conceived. Astronomers use it to decode the composition of stars billions of light years away. But on Earth, the same principle is used for espionage. Intelligence agencies can analyze the light signatures from the exhaust plume of a missile test to determine the chemical makeup of its fuel. They can fly a specialized aircraft along a nation's border and sniff the atmosphere for the spectral fingerprints of specific elements associated with nuclear weapons development. There is no need to place a spy on the ground. The light itself is the informant, carrying an indelible message about the secret activities it has witnessed. The sun's own light, when analyzed, reveals dark lines where elements in its atmosphere have absorbed specific colors, a detailed chemical inventory of our star. The same technique applied to a suspicious industrial facility can reveal its true purpose. This brings us to perhaps the most stunning demonstration of our ability to read light's hidden messages: the hunt for distant worlds. Astronomers have discovered thousands of planets orbiting other stars using a method of breathtaking sensitivity. They stare, unblinking, at a single star, measuring its brightness with incredible precision. If a planet happens to pass in front of that star, it will block a tiny fraction of its light, causing a slight, almost imperceptible dip in its brightness. From the timing and depth of these repeating dips, analysts can deduce the planet's size and orbit. They can even read the faint spectral signatures imprinted on the starlight as it filters through the planet's atmosphere, revealing the presence of gases like water vapor or methane. This is the ultimate signal and noise problem. The overall mood and analytical equivalent of trying to detect a single whispered conversation in the roar of a crowded stadium. The algorithms and sensors developed for this astronomical quest are, by their very nature, dual use. The same system that can detect the shadow of a planet trillions of miles away can be repurposed to detect the faint thermal signature of a stealth bomber against the cold background of the sky, or to isolate a weak encrypted radio transmission from the static of deep space. The search for other worlds is not just a journey of discovery. It is a state-sponsored global R&D program for perfecting the art of remote detection. Light, even in its faintest and most subtle modulations, is a carrier of secrets, waiting for an instrument sensitive enough to read them. The vast quantities of data we gather from space, from our surveillance networks, from the global economy, all of it is worthless unless it can be moved. We speak of the cloud as if it were an ethereal, placeless entity. This is a dangerous deception. The cloud has a physical body, a terrestrial nervous system of immense strategic importance, and most of it lies here, in the cold, dark, and crushingly hostile environment of the ocean floor. Beneath the waves, a network of glass fibers, some no thicker than a human hair, spans entire continents. These are the submarine fiber optic cables, and they are the true arteries of globalization. Over 99% of all international data, from financial transactions and diplomatic cables to military commands and video streams, travels not through satellites, but as pulses of light through these undersea strands. The system works on a principle of elegant simplicity: total internal reflection. Light is beamed into the glass core at such a shallow angle that it cannot escape, bouncing endlessly off the inner walls of the fiber with almost no loss of signal. Compared to the old copper wires they replaced, these fibers are a quantum leap forward. The photons that race through them are immune to the electrical interference and signal degradation that plagued older systems. This allows information to travel farther, faster, and with greater clarity than ever before. This is the technological backbone of our civilization, a system that moves data at nearly the speed of light. But its efficiency is matched only by its vulnerability. This global nervous system has choke points. A handful of landing sites, often in politically unstable regions, concentrate dozens of these critical cables. And the cables themselves, snaking for thousands of miles across geologically active seabeds, are susceptible to damage from ship anchors, earthquakes, and, most ominously, deliberate sabotage. A hostile state, or even a well-equipped terrorist group with access to a submarine, could sever a nation's primary connection to the outside world, effectively unplugging it from the global economy and isolating its military forces. This is not a hypothetical threat. Intelligence agencies around the world actively monitor the suspicious movements of rival nations' submarines and research vessels near these critical cables. The potential for data espionage, physically tapping a fiber optic cable on the ocean floor to siphon off vast amounts of unencrypted information, is a constant and terrifying reality. The race is on to develop new quantum encryption methods that would make such eavesdropping impossible. But for now, the data flowing through these glass tubes remains a tempting target. This has ignited a new great game beneath the waves. The United States and China are now locked in a fierce competition to finance, build, and control the next generation of undersea cables. The nation that lays the cable often sets the standards for the technology and can potentially build in back doors for intelligence gathering. Control the physical infrastructure of the internet, and you control the flow of information for entire continents. It is a new form of digital colonialism, fought with survey ships and cable-laying barges in the silent darkness of the deep sea. The sheer capacity of this network is staggering, made possible by a technique known as wavelength division multiplexing. Each individual fiber can carry dozens of separate data streams at once, simply by using different colors, different wavelengths of light. Each color acts as its own private high-speed channel. A single hair-thin strand of glass is thus transformed into a superhighway with 100 lanes, each lane carrying billions of bits of information per second. The combined capacity is almost beyond comprehension. The entire contents of the Library of Congress can be transmitted across the Atlantic in a matter of seconds. But this immense power is a double-edged sword. Our total dependence on this system means that its failure would be catastrophic. The world's financial markets, which trade trillions of dollars a day based on algorithmic decisions made in microseconds, would be thrown into chaos. Military command and control systems, which rely on high-bandwidth satellite uplinks connected to these terrestrial networks, would be crippled. The quiet, almost invisible glow within these fibers is not just data, it is the lifeblood of modern power, and it is more fragile than we dare to imagine. In our world, beauty is often a mask for profound danger. Consider the soap bubble. Its surface shimmers with a shifting, ethereal rainbow of colors. The beauty is not born from pigment. It is the result of a physical phenomenon known as thin film interference, and it is a perfect illustration of the fragile and deceptive nature of modern technology. The bubble's wall is an impossibly thin layer of water, and as light strikes it, some reflects from the outer surface while the rest travels through and reflects off the inner surface. These two reflected waves then interfere with each other. Where their crests align, a color is amplified. Where a crest meets a trough, the light is canceled, leaving nothing. The result is a vibrant, moving pattern of color created not by substance, but by geometry and wave cancellation. This is not just a child's toy. It is a physical demonstration of the foundational principle of electronic warfare. The goal of a modern electronic warfare system is not to create a bigger explosion, but to create a more perfect silence. It is to generate a signal that can perfectly interfere with and cancel out an adversary's radar or communication system. It is to turn their sensor screens into a cascade of meaningless shimmering noise, or better yet, to make a real target vanish completely. The shifting, fragile colors on the bubble surface are a metaphor for the state of our digital infrastructure. Our global communication network, our financial markets, our military command systems, all are built on a thin film of perfectly aligned signals. A sophisticated jamming attack, a burst of destructive interference, can cause that film to collapse in an instant, turning order into chaos. The beauty of the bubble is its fragility. As the film thins and drains, the colors shift and then vanish. The overall mood is an ephemeral state, a momentary balance of wave paths that can be disrupted with devastating speed. But what if you could engineer a surface that did not just create random patterns, but controlled them? What if you could build a material that was designed at a microscopic level to cancel out specific colors and amplify others, not by accident, but by design? For this, military engineers are turning to nature's own masters of stealth and deception. The wings of many butterflies display colors of an impossible vibrancy, hues that never fade over time. This is because, like the soap bubble, they contain no pigment. Their color is structural. Under a microscope, their wing scales are revealed to be covered in tiny, precisely spaced ridges and layers. These nanostructures act as sophisticated diffraction gratings, physically manipulating the waves of incoming light. They are engineered to surgically select which wavelengths to reflect and which to cancel out. The result is a pure, intense color born not from chemistry, but from physics. This is the holy grail of stealth technology. Traditional camouflage is, at its heart, just pigment, paint. It has a chemical signature, it degrades, and most importantly, it is static. A green pattern that works in a forest is a death sentence in a desert. But a material based on structural color could, in theory, be tunable. By altering the microscopic spacing of its surface, it could change its appearance in real time, creating the ultimate adaptive camouflage. This is the science of metamaterials, artificial structures designed to bend light in ways that nature never intended. The goal is to create surfaces that can render an object invisible, not by absorbing light, but by perfectly guiding it around the object as if it were never there. The blueprint for this revolutionary technology flies freely in the wild. The shimmering, iridescent sheen of a butterfly's wing is a proof of concept for a new arms race in the field of material science. The nation that perfects this will be able to build aircraft, ships, and soldiers that can literally disappear from sight. The quiet flutter of a wing is a whisper of a future where invisibility is no longer fiction. And in some cases, the deception is even more complex, designed not just to hide, but to confuse. The feathers of a hummingbird shift from emerald to ruby as it moves, a dazzling display that is also based on layered microstructures. But here, the color is entirely dependent on the angle of the observer. From one perspective, the bird is a brilliant green. From another, it is a fiery red. This is a masterclass in perception management. It demonstrates that the signature of an object is not a fixed reality, but a variable dependent on the observer. This principle is at the heart of modern stealth aircraft design. An F-35's radar cross-section, its color on a radar screen, is not one single value. It is dramatically different depending on whether it is being viewed from the front, the side, or from below. The entire shape of the aircraft is a carefully sculpted geometric form designed to deflect radar waves away from the enemy's sensors, presenting a different, much smaller signature depending on the angle of engagement. The bird and the fighter jet both teach the same ruthless lesson. What your enemy sees depends entirely on where you force them to look from. In the world of high strategy, there are certain assets whose value is derived not from brute force, but from their ability to manipulate the very fabric of reality. The diamond is the ultimate symbol of this power. To the layperson, it is a stone of beauty and wealth. To a physicist, it is a near-perfect carbon lattice with an exceptionally high refractive index. But to a strategist, it is a masterclass in controlled information. The fire and sparkle of a diamond are not inherent properties. They are the result of a deliberate, calculated, and ruthless process of engineering. When light enters the stone, it is bent and trapped, forced to reflect internally off precisely angled facets before it is permitted to escape. Each bounce splits the light, dispersing it into a spectrum of pure color. A well-cut diamond is a weaponized prism, designed not just to reflect light, but to capture it, analyze it, and return it to the eye with maximum brilliance. A poorly cut stone, by contrast, leaks light and appears lifeless. This is the perfect metaphor for a national intelligence apparatus. Raw information, like raw light, is abundant but chaotic. It is the quality of the cut, the precision of the analytical framework, the skill of the operators, the architecture of the system that determines whether that raw data is transformed into brilliant, actionable intelligence or whether it leaks away into darkness. The diamond also serves as a stark lesson in resource control. The global diamond market has been, for much of its history, a tightly controlled cartel, a manufactured scarcity designed to inflate value. The overall mood of intelligence, supercomputers, quantum sensors, advanced algorithms, are themselves strategic resources. Their export and proliferation tightly controlled by the handful of nations that possess them. The flashes of fire from a diamond are a projection of power, a demonstration of the ability to impose order on a natural force. But this terrestrial perfection stands in stark contrast to the greatest challenge facing any Earth-based intelligence system: the chaos of our own atmosphere. The steady, unwavering light from a distant star embarks on its journey as a perfect, coherent beam. But in the final microseconds of a voyage that may have lasted millennia, it must pass through the turbulent, shifting layers of Earth's air. Each layer, with a slightly different temperature and density, acts as a flawed, unpredictable lens, bending the light in random directions. The result is what we poetically call twinkling. But for an astronomer, a military satellite operator, or a laser weapons engineer, it is a critical and infuriating problem. It is signal degradation. It is noise. This atmospheric distortion is the mortal enemy of clarity. It blurs the images from our most powerful ground-based telescopes and can cause a high-energy laser beam to lose its focus, scattering its power harmlessly before it can reach its target. Planets appear steadier simply because they are closer and present a larger disk, their light averaging out the distortions, a small statistical mercy in a sea of atmospheric chaos.
For decades, the brightest minds in defense and astronomy have been locked in a war against this turbulence. The primary weapon in this fight is a technology called adaptive optics.
A natural male narrator with a warm, friendly tone. The overall mood is a stunningly clear, stable image, a star that no longer twinkles. This is not just an academic tool. The same technology that gives an astronomer a clear view of a distant galaxy is used to keep a laser weapon locked on to a fast-moving missile, or to ensure that a secure laser communication link between a ground station and an orbital satellite remains unbroken. But even this is a compromise. The ultimate solution to the problem of the atmosphere is not to fight through it, but to rise above it. This is why space is the ultimate high ground. A telescope in orbit operates in a perfect silent vacuum, free from the blurring, distorting, and light-absorbing blanket of our air. Space-based platforms like the Hubble and James Webb telescopes are not just instruments of science, they are demonstrations of ultimate strategic overmatch. Freed from atmospheric turbulence, their vision is limited only by the laws of physics itself. They capture images of a clarity and depth that is physically impossible to achieve from the ground. They can also see in wavelengths, like infrared and ultraviolet, that our atmosphere normally blocks, opening up entirely new windows of intelligence. A satellite that can see in the deep infrared can detect the faint heat of a hidden underground facility, while one sensitive to ultraviolet can analyze the chemical residues of a weapons test. When you see a breathtaking photograph of a distant galaxy released to the public, you are seeing a product of this immense technological advantage. The universe is not a static stage. It is intercepting messages from 400 miles up. The clarity is absolute. And with that clarity comes a power that is almost divine. The power to look back in time. The power to see into the past is the ultimate form of strategic intelligence. An orbiting telescope like Hubble is not just collecting photons. It is intercepting messages from a former universe, a cosmos that was younger, more violent, and still taking shape. But as this ancient light travels across the expanding fabric of space-time, it is fundamentally altered. The universe is not a static stage. It is an actively growing, evolving entity. And as the distance between galaxies stretches, the very light traveling through that space is stretched along with it. This process lengthens the light's wavelength, shifting it inexorably toward the red end of the spectrum. This is cosmological redshift. It is not the familiar Doppler effect of a siren changing pitch as it passes by. This is the signature of space-time itself expanding between the source and the observer. For an intelligence analyst, this is the most profound form of passive surveillance imaginable. The degree of redshift is a direct, unforgeable measurement of a galaxy's distance and the speed at which it is receding from us. The redder the light, the older and more distant the source. This single principle is the foundation of modern cosmology, the proof that our universe is not a timeless, static void, but a dynamic and evolving structure. The most remote galaxies we can detect appear as faint, deep red smudges, their light stretched and weary from a journey of over 13 billion years. That ancient red glow is an intelligence report on the state of the universe during its formative years. It tells us not only how galaxies were born, but how the very laws of physics may have operated in that primordial era. But redshift also defines the absolute limits of our vision. There is a cosmic horizon, a point in space-time so distant that the light from beyond it, stretched by the expansion of the universe, will never have time to reach us. This is the edge of our knowable universe, a fundamental boundary to our intelligence-gathering capabilities. This stretching of light across cosmic distances, however, masks an even more profound and unsettling truth. From our perspective, the journey of a photon from a distant quasar takes billions of years. But from the perspective of the photon itself, the journey is instantaneous. According to Einstein's theory of relativity, as an object approaches the speed of light, its experience of time slows down relative to a stationary observer. At the speed of light, this effect is absolute. Time stops completely. For a photon, there is no passage of time. The moment of its creation and the moment of its arrival are one and the same instant. The billions of years and trillions of miles of its voyage collapse into a single, timeless event. This is not a philosophical metaphor, it is a physical reality. The light striking your eye from the Andromeda galaxy, which we measure as having traveled for 2.5 million years, experiences no journey at all. This concept has staggering implications for our understanding of information. It implies that every point in the universe is connected to every other point by a web of these timeless, instantaneous pathways. The information carried by light is not degraded by the passage of time because, for the carrier, time does not exist. This is the theoretical bedrock of future communication systems. If we can learn to encode and decode information on single photons without destroying their quantum state, we could create a communication channel that is, in a very real sense, timeless. The universe, it turns out, is the ultimate point-to-point network, and light is its perfect zero-latency protocol. It is a bridge across space-time that joins the origin and the observer without delay. In the photon's own frame of reference, existence is a single eternal now. This timeless, weightless messenger, however, is not immune to the most powerful force in the cosmos. Light travels in a straight line, but the universe itself is not straight. And the force that bends the universe is gravity. In the early 20th century, Albert Einstein proposed a truth so radical it threatened to shatter our perception of reality. He declared that gravity was not a mysterious force acting at a distance, but a consequence of the curvature of space-time itself. Mass, he argued, tells space how to bend, and space tells matter how to move. But he made an even bolder prediction, that this curvature would not only dictate the motion of planets and stars, but also the path of light itself. A beam of light, though massless, would be forced to follow the contours of this warped geometry. This was a testable hypothesis, a direct challenge to the classical world, and the ultimate testing ground would be the sun. During a total solar eclipse, when the moon's shadow would briefly blot out our star's blinding glare, a daring experiment could be conducted to photograph the stars appearing right next to the sun's edge and compare their positions to normal. In 1919, expeditions were dispatched to Brazil and Africa. The photographs they returned with changed the world forever. The starlight had been bent, its position shifted by the sun's immense gravity, by the exact amount Einstein's equations had predicted. The confirmation was a global event, cementing a new understanding of the universe and transforming our conception of gravity. But for strategists, the implications were even more profound. This experiment proved that the very fabric of the universe could act as an optical instrument. It demonstrated that the most massive objects in the cosmos could be used as lenses. This was not a technology we needed to invent. It was a physical reality we only needed to learn how to exploit. And on a cosmic scale, the power of these natural lenses is almost beyond belief. Massive clusters of galaxies, containing the mass of a quadrillion suns, act as colossal magnifying glasses, bending and focusing the light from objects lying billions of light years behind them.
This phenomenon, known as gravitational lensing, is the universe providing us with a free telescope of unimaginable power. It allows our own, much smaller instruments to study galaxies that would otherwise be far too faint and distant to ever detect. But the image it provides is not a simple, clear picture. It is a funhouse mirror of cosmic proportions. The intense gravity warps the background light into distorted arcs, rings, and multiple mirrored images of the same galaxy. For astronomers, this distortion is a gift.
A natural male narrator voice with a warm, friendly tone. Fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8. By analyzing the precise shape and location of these warped images, they can calculate the mass of the foreground cluster with incredible accuracy. And in doing so, they discovered the greatest secret of the cosmos. The visible matter in these clusters, the stars, gas, and dust, was not nearly massive enough to produce the lensing effect they were observing. There had to be something else there, something invisible, something that did not interact with light, but whose gravitational presence was undeniable. This was the discovery of dark matter. Gravitational lensing became the only tool capable of mapping the location and distribution of this mysterious, unseen substance that constitutes over 80% of the matter in the universe. This is a lesson of supreme importance for the world of intelligence. It proves that it is possible to map an adversary's hidden power structure without ever seeing it directly. An organization's dark matter, its secret funding, its covert political influence, its network of shell corporations, can be mapped by observing its gravitational effect on the visible world, on financial markets, on political outcomes, on the flow of resources. The principle is identical. You map the invisible by meticulously analyzing its distortion of the visible. Gravitational lensing is therefore not just an astronomical curiosity. It is the universe's own masterclass in intelligence gathering, demonstrating how to turn an enemy's greatest strength, their mass, their power, into a tool that can be used against them to reveal their deepest secrets. There is a limit to the power of gravity, a point where the curvature of space-time becomes infinite, where the laws of physics as we know them break down. This is the singularity, the heart of a black hole. Its boundary, the event horizon, is the most absolute border in the universe. A natural male narrator with a warm, friendly tone. It is not a physical surface, but a point of no return. Anything that crosses it, matter, energy, light itself, can never escape. But just outside this abyss, in the final desperate millimeters of space-time, light wages its most dramatic battle. A photon attempting to escape the black hole's titanic pull must fight against a gravitational field so extreme that it loses energy with every inch it climbs. This forces its wavelength to stretch, shifting it further and further down the red end of the spectrum. To a distant observer, this gravitational redshift would make the light appear to slow and fade, freezing for an eternity at the edge before vanishing into blackness. This is the ultimate information death. The final message from whatever fell in is stretched thin across eternity, its energy bled out by the sheer weight of space-time itself. Yet, in the region just outside the event horizon, an even stranger phenomenon occurs. Here, gravity is so perfectly and savagely balanced that a photon can be trapped in a perfect circular orbit, looping around the black hole forever. This is the photon sphere.
In theory, it is a ring of pure orbiting light, the last possible stable path before the final plunge. The bright golden ring that humanity first captured in an image of a black hole is the light from this very region. We are seeing photons that may have circled the abyss countless times before finally being flung in our direction, carrying a direct report from the edge of oblivion. The ability to image this structure is not just a scientific triumph. It is a statement of geopolitical power, requiring a global network of telescopes, supercomputers, and international cooperation on an unprecedented scale. But these gravitational monsters are not just passive endpoints of stellar evolution. In the centers of young, violent galaxies, they are the engines for the most luminous objects in the universe, quasars. A quasar is powered by a supermassive black hole, millions or billions of times the mass of our Sun, actively feeding on a torrent of gas, dust, and shredded stars. As this matter spirals inward, it is crushed and heated by friction and magnetic fields to millions of degrees, unleashing a storm of radiation so intense that it can outshine all 100 billion stars of its host galaxy combined. From across the universe, they appear as points of impossible star-like brilliance. But each one marks the site of a cosmic engine of almost unimaginable violence. Quasars are the ultimate paradox of destruction and illumination. They are gravity's hunger made manifest, consuming entire star systems, yet they transform that destruction into the purest and most powerful light, a beacon that can be seen across the entire observable universe. For intelligence analysts, they are invaluable tools. Their intense light travels for billions of years through the seemingly empty void between galaxies. By analyzing the spectral lines of that light, astronomers can see what it has passed through, revealing the chemical composition and structure of the invisible intergalactic medium. The quasar acts as a cosmic flashlight, illuminating the vast dark territories of the universe that would otherwise remain hidden. In this, they serve as a powerful analogy. Sometimes the most catastrophic and destructive event is the very thing that illuminates the hidden structures of the world, revealing connections and vulnerabilities that were invisible in times of peace. Light from the edge of destruction becomes the ultimate tool of discovery. There is a limit to the power of gravity.
A natural male narrator voice with a warm, friendly tone, fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8, a point where the curvature of space-time becomes infinite, where the laws of physics as we know them break down. This is the singularity, the heart of a black hole. Its boundary, the event horizon, is the most absolute border in the universe. It is not a physical surface, but a point of no return. Anything that crosses it, matter, energy, light itself, can never escape. But just outside this abyss, in the final desperate millimeters of space-time, light wages its most dramatic battle. A photon attempting to escape the black hole's titanic pull must fight against a gravitational field so extreme that it loses energy with every inch it climbs. This forces its wavelength to stretch, shifting it further and further down the red end of the spectrum. To a distant observer, this gravitational redshift would make the light appear to slow and fade, freezing for an eternity at the edge before vanishing into blackness. This is the ultimate information death. The final message from whatever fell in is stretched thin across eternity,
its energy bled out by the sheer weight of space-time itself. Yet, in the region just outside the event horizon, an even stranger phenomenon occurs. Here, gravity is so perfectly and savagely balanced that a photon can be trapped in a perfect circular orbit, looping around the black hole forever. This is the photon sphere. In theory, it is a ring of pure orbiting light, the last possible stable path before the final plunge. The bright golden ring that humanity first captured in an image of a black hole is the light from this very region. We are seeing photons that may have circled the abyss countless times before finally being flung in our direction, carrying a direct report from the edge of oblivion.
The overall mood of scientific triumph, it is a statement of geopolitical power, requiring a global network of telescopes, supercomputers, and international cooperation on an unprecedented scale. But these gravitational monsters are not just passive endpoints of stellar evolution. In the centers of young, violent galaxies, they are the engines for the most luminous objects in the universe, quasars. But quasar is powered by a supermassive black hole, millions or billions of times the mass of our Sun, actively feeding on a torrent of gas, dust, and shredded stars. As this matter spirals inward, it is crushed and heated by friction and magnetic fields to millions of degrees, unleashing a storm of radiation so intense that it can outshine all 100 billion stars of its host galaxy combined. From across the universe, they appear as points of impossible star-like brilliance, but each one marks the site of a cosmic engine of almost unimaginable violence. Quasars are the ultimate paradox of destruction and illumination. They are gravity's hunger made manifest, consuming entire star systems, yet they transform that destruction into the purest and most powerful light, a beacon that can be seen across the entire observable universe. For intelligence analysts, they are invaluable tools. Their intense light travels for billions of years through the seemingly empty void between galaxies. By analyzing the spectral lines of that light, astronomers can see what it has passed through, revealing the chemical composition and structure of the intergalactic medium. The quasar acts as a cosmic flashlight, illuminating the vast, dark territories of the universe that would otherwise remain hidden. In this, they serve as a powerful analogy. Sometimes, the most catastrophic and destructive event is the very thing that illuminates the hidden structures of the world, revealing connections and vulnerabilities that were invisible in times of peace. Light from the edge of destruction becomes the ultimate tool of discovery. In the early 20th century, a new kind of light captivated the world. It was a soft, ethereal, self-sustaining glow, a symbol of scientific progress and modern luxury. Glow-in-the-dark watches and clocks became the must-have accessories of a generation embracing a new technological dawn. The magic came from a paint infused with two ingredients, a phosphorescent compound and a newly discovered miracle element called radium. The intense radiation from the radium atoms constantly bombarded the surrounding material, causing it to emit a steady, ghostly green light. No batteries or sunlight required. It was chemistry as magic, a captured star on your wrist. But this seductive glow concealed a lethal secret. In factories across the country, young women, later known as the radium girls, were employed to paint the tiny numbers onto watch faces. To give their brushes the finest possible point, they were instructed to lick the tips, ingesting small amounts of the radioactive paint with every stroke. They were told the material was harmless. It was a lie.
The radium, chemically similar to calcium, was absorbed by their bodies and settled in their bones, where it began its slow, silent, and gruesome work. The constant internal bombardment of radiation caused their skeletons to crumble, their jaws to disintegrate, and their bodies to be ravaged by cancers. The tragedy of the Radium Girls was a landmark event in industrial history. Their fight for justice against a corporation that knowingly poisoned them for profit became a catalyst for revolutionary change. It led to the establishment of modern occupational safety standards, the recognition of industrial diseases, and the creation of government agencies with the power to regulate workplace safety. It was a brutal lesson, paid for in lives, about the profound responsibility that comes with wielding a new scientific power. The overall move of those watch dials was not just light, it was an early warning about the dark side of technological progress, a story of corporate negligence and the birth of the modern labor rights movement. As the dangers of radioactive light became horrifyingly clear, a new, safer technology was already on the horizon, one that would fundamentally reshape the 20th century world: the fluorescent lamp. Its genius lies in a two-step transformation. Inside the glass tube, an electric current excites a low-pressure gas, causing it to emit high-energy but completely invisible ultraviolet radiation. This UV light then strikes a phosphor coating on the inside of the tube. The phosphor absorbs the invisible energy and re-emits it as visible light. This elegant process was a quantum leap in efficiency, producing brilliant illumination with far less heat than the incandescent bulbs that came before it. But its true impact was not just in saving energy, it was in changing the very architecture of society. The fluorescent light made the modern 24-hour indoor world possible. The vast office buildings, the sprawling factory floors, the sterile hospitals, all were made economically viable by this efficient, mass-produced form of light. It fueled the growth of cities and the rise of the second and third work shifts, fundamentally altering humanity's relationship with the rhythm of day and night. But even this revolution was just a prelude. The late 20th century saw the birth of a technology that would make all previous forms of lighting obsolete: the light-emitting diode, or LED. It is not a bulb, it is a semiconductor, a tiny crystal chip that creates light through the controlled movement of electrons. When electricity is applied, electrons are forced across a junction between two different types of semiconductor material. As they cross, they release their excess energy not as heat, but as a single, pure photon of light. The color of that light is determined with surgical precision by the chemical composition of the crystal. This is not just a more efficient light bulb, it is a complete paradigm shift. Because LEDs are semiconductor devices, they can be controlled with the same microprocessors that run our computers. They can be made infinitely small, incredibly durable, and networked into vast, intelligent systems. This has enabled the massive video walls that define our modern cityscapes, the precise, color-tuned lighting that makes indoor vertical farming possible, and the rapid adoption of energy-saving technology on a global scale. The transition to LED lighting is one of the most significant and least celebrated factors in the global effort to reduce energy consumption and combat climate change. The humble LED is not just a light source, it is a strategic asset, a key piece of the digital revolution, and a technology whose supply chain is now a major arena of geopolitical competition. The quiet, efficient glow of a modern LED is the culmination of a century-long quest to master the art of artificial light, a journey that began with a dangerous radioactive glow and has ended with a clean, digital, and globally transformative fire. For the entirety of human history, our species has lived under a managed perception of reality. Our most fundamental truth, the color of our own sun, is a lie. It is a deception engineered not by a foreign power, but by our own planet's atmosphere. When viewed from the unfiltered high ground of space, the sun is not yellow or golden. It is a searing, brilliant, and pure white, a balanced torrent of every visible color.
The golden sun we have written into our poetry, our art, and our psychology is an illusion, a filtered signal. As sunlight plunges through our air, the shorter blue wavelengths are violently scattered away, leaving a residual beam that appears warmer, yellower, and gentler than it truly is. Our atmosphere is the most effective information filter in existence. It has, for millennia, protected us from the harshest radiation of our star. But in doing so, it has provided us with a comfortable, modified truth. This is a profound lesson in the nature of intelligence and propaganda. What we perceive as the absolute ground truth reality is often just the part of the signal that has survived its journey through a distorting medium. The truth on the ground is rarely the whole truth. It is incumbent upon any intelligence service to strive for the view from space, to bypass the atmospheric noise of public opinion, official state narratives, and cultural bias to see the raw, unfiltered, white-hot reality of a situation. The golden sun we see is a form of planetary censorship. A benign one, but a powerful reminder that our senses can be easily deceived by the very environment we depend on for survival. But even on the ground, the light we create ourselves tells a story of stability or the lack thereof. The simple flame of a candle, a symbol of peace and contemplation, is in reality a system in a state of continuous, violent crisis. Its soft glow is the visible evidence of a desperate and unstable balancing act between fuel, heat, and oxygen. The gentle flicker is a constant struggle against collapse, a momentary wavering caused by the slightest disturbance in the surrounding air. To a strategist, a candle flame is the perfect model for a fragile state, a volatile market, or a tense military standoff. It is a system that appears stable from a distance, but up close is revealed to be on the precipice of chaos, its very existence dependent on a delicate, uninterrupted flow of resources. The golden color of the flame comes not from the clean burning of gas, but from incandescent particles of soot, impurities, and byproducts of an incomplete combustion process. Paradoxically, it is these imperfections that make the flame so visible to us. This is another fundamental truth of intelligence. A perfectly efficient, clean operation is often invisible. It is the friction, the waste, the soot of a system, the black market activity, the political corruption, the logistical failures that often generates the most visible and useful signals for an outside observer. Just as the sun's light is filtered by our atmosphere, so too is it modified by reflection. The moon, our silent companion in the night sky, has no light of its own. It is a passive actor on the celestial stage, its power entirely borrowed. The light we call moonlight is nothing more than second-hand reflected sunlight, a laundered signal that has been fundamentally altered by the surface it has struck. The moon's dusty, rocky surface is an imperfect mirror. It absorbs some wavelengths and reflects others, giving its light a subtly different character, a ghostly pallor compared to the original. This is the perfect analogy for the relationship between a superpower and a proxy state. The proxy has no inherent power. It merely reflects the strategic interests and ideology of its patron. But it is never a perfect reflection. The signal is always distorted by the local terrain, the region's culture, politics, and history. The overall moonlight is not the sunlight, and the actions of a proxy are never a perfect representation of the patron's will. For an intelligence agency, the challenge of attribution is immense. To understand the light from the moon, you must first understand the sun that shines upon it. But you must also analyze the precise, distorting properties of the mirror itself. But there are forces on our own planet that can generate light in ways that defy all these models. During a major volcanic eruption, as a mountain tears itself apart, a new and terrifying storm can be born within the towering plume of ash and gas. As billions of superheated rock fragments and ice crystals collide, they strip electrons from one another, turning the entire cloud into a massive electrostatic generator. The result is volcanic lightning, a spectacular and horrifying display of raw geological power transforming into atmospheric fury. This is a multi-domain crisis, a geological event triggering a meteorological one, a system of systems failure of apocalyptic proportions. For remote sensing and surveillance, it is an event of supreme importance. The volcanic lightning creates a powerful secondary signal, a burst of radio waves and brilliant light that can be detected from hundreds of miles away, even when the volcano itself is shrouded in an impenetrable cloud of its own making. The light born from the chaos becomes the primary indicator of the chaos's scale and intensity. It is a terrifying lesson that in the world's most extreme events, the disaster itself creates its own beacon, a flash of lightning that illuminates the heart of the storm. The most sophisticated sensor on any battlefield is not a piece of technology. It is the human operator. For decades, military science has focused on augmenting this operator with armor, advanced weaponry, and networked information.
The next frontier of warfare is not external, it is internal. It is the systematic exploitation of the human body's own ancient, hardwired vulnerabilities. And the most powerful tool for this exploitation is light. Our bodies are not passive observers of the world, they are deeply interconnected with it. Our skin, our eyes, our very cells are a network of photosensitive receptors, constantly reacting to the ambient light in our environment, often in ways that bypass our conscious mind entirely. Even through closed eyelids, light penetrates and signals the brain, helping to regulate the intricate hormonal cycles that govern our sleep, our mood, and our cognitive performance. This is the science of circadian rhythm, and in the world of national security, it is no longer a niche field of biology. It is a critical domain of human factors engineering. Consider the crew of a nuclear ballistic missile submarine on a months-long deterrent patrol. They live in a steel tube deep beneath the waves, completely severed from the natural cycle of day and night. Yet their alertness, their ability to make split-second decisions under unimaginable pressure is paramount. To maintain operational readiness, their environment is a meticulously controlled stage of artificial light, with a carefully programmed cycle of daylight and darkness designed to trick their brains into maintaining a stable rhythm. The same is true for astronauts on the International Space Station, and for analysts buried deep within windowless subterranean command centers like Cheyenne Mountain. In these environments, light is not illumination, it is a pharmaceutical, a tool used to manage the biological clocks of the nation's most critical personnel. A failure in this system, a disruption of this delicate hormonal balance, can lead to fatigue, poor judgment, and catastrophic error.
The overall marvel of evolutionary engineering is a marvel of evolutionary engineering. Step from bright sunlight into a dark room, and within seconds, a cascade of physiological adjustments occur.
The pupils dilate, and the chemical sensitivity of the retina is recalibrated, allowing us to see in the shadows. But this remarkable adaptation is also a profound vulnerability. A flashbang grenade does not wound with shrapnel, it wounds with photons. The sudden, overwhelming blast of light is designed to deliberately overload this adaptive system, causing instantaneous, temporary blindness and overwhelming the brain's sensory processing. In the world of non-lethal weaponry, light itself has been weaponized to disorient and incapacitate. Advanced systems now use strobing lights at specific frequencies that are known to induce feelings of nausea, vertigo, and even epileptic-like seizures in a small percentage of the population. This is the art of turning the body's own protective mechanisms against itself. This biological manipulation extends to the very chemistry of our mood and motivation. Exposure to sunlight, specifically the blue wavelengths within it, stimulates the release of serotonin, a neurotransmitter that promotes feelings of well-being and focus. In parallel, it suppresses the production of melatonin, the hormone that induces sleep. This ancient biological link to the sun is the reason why a bright morning can feel energizing, and why long, dark winters can lead to a form of depression known as seasonal affective disorder. For military forces stationed in the high Arctic, or for intelligence officers on long-term assignments in Northern Europe, this is not a minor inconvenience. It is a serious threat to operational readiness and mental health. Unnatural military bases in these regions are now equipped with specialized full-spectrum lighting systems designed to mimic the hormonal effects of natural sunlight, a therapeutic use of light to maintain the psychological resilience of the force. But the most insidious threat is the one we have inflicted upon ourselves. The glow of our electronic screens, our computers, our tablets, our phones, is heavily biased towards the blue end of the spectrum. To our brain, this digital light is a powerful mimic of midday sun. When we stare at these screens late at night, we are sending a powerful, unambiguous signal to our hormonal system: it is noon, stay awake. This suppresses the natural evening rise of melatonin, making it difficult to fall asleep and degrading the quality of the rest we do get. The modern warfighter, the drone pilot, the cybersecurity analyst, all are required to spend countless hours absorbing information from these very screens. Their effectiveness, their very survival, depends on it. Yet the tool they use is systematically degrading their cognitive performance by disrupting their most fundamental biological rhythms. This is a systemic, self-inflicted vulnerability across the entire modern military and intelligence apparatus. Light discipline, once a term that meant simply turning off a flashlight in the dark, now refers to managing the color temperature of our screens and limiting our exposure to the silent hormonal weapon that is blue light. The battle for cognitive superiority in the 21st century has moved from the classroom to the command center, and it may well be won or lost not by the power of our processors, but by our ability to manage the impact of their glow on the fragile biological systems of the human mind. The overall mood has given us the 24-hour city, the tireless factory, and the sleepless command center. But this mastery has come at a steep and often invisible price. With every new street lamp, every illuminated skyscraper, every glowing advertisement, we have waged a war against darkness, and we have won so decisively that we have erased our own history. For millennia, the night sky was humanity's common heritage, our first map, our first calendar, and our first source of cosmic awe. Today, for the vast majority of the world's population, it has been almost completely obliterated. This is light pollution, a form of self-inflicted blindness. In our major urban centers, a suffocating dome of our own scattered light
has washed out all but the brightest stars and planets from view, severing a connection to the universe that had defined the human experience since our species was born. This is not merely an aesthetic loss, it is a strategic and ecological crisis. Migratory animals that have navigated by starlight for millions of years are now fatally disoriented by the perpetual twilight of our cities. Nocturnal ecosystems are thrown into chaos. But for a civilization that is increasingly dependent on space, this self-made glare is a profound vulnerability. The very sky glow that hides the stars can also blind our own ground-based observatories, making it more difficult to track near-Earth asteroids, monitor the movements of foreign satellites, or receive faint signals from deep space probes. We have surrounded ourselves with a curtain of our own light, making it harder to see the threats that are coming from the darkness beyond.
The overall mood, shielding lights to direct them downward, and by using warmer, less scattering color temperatures, are not just environmental initiatives, they are matters of planetary security, a fight to reclaim the clarity of the night sky for the critical work of astronomy and defense. But the power of light has always been about more than just seeing. It is about feeling. For centuries, artists, architects, and storytellers have intuitively understood what science is only now quantifying, that the color of light is a powerful tool for emotional manipulation. Warm light, with its reddish and golden tones, mimics the ancient primal safety of the campfire and the hearth. It triggers a deep-seated psychological response, conveying intimacy, comfort, and security. Cool light, tinged with blue, evokes the vast, impersonal emptiness of the open sky or the deep sea. It can create feelings of isolation, melancholy, or sterile efficiency. This is not subjective interpretation. It is a measurable biological response. Warm light can gently increase heart rate and draw focus inward, while cool light can have a calming or even saddening effect. This ancient artistic knowledge has now been fully weaponized in the world of media, propaganda, and psychological operations. Cinematographers use this color temperature to control an audience's emotional response with surgical precision. A scene of a family reunion is bathed in a warm, golden glow to evoke nostalgia and love. The very same location, lit with cold, blue-tinted light, becomes the setting for a scene of alienation and dread. Political advertisements, corporate branding, and state-sponsored media are all meticulously color-graded to elicit a specific, desired emotional state in the viewer.
The overall mood is relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The light is the message. To counter such manipulation and to extract truth from a flood of visual data, the intelligence analyst must learn to deconstruct light. Just as a prism breaks white light into its constituent colors, a modern intelligence analyst uses a digital toolkit of filters to dissect an image or video feed. A simple satellite photograph, to the naked eye, is a single picture, but to an analyst, it is a layered stack of data. By applying a filter that isolates the specific wavelength of light reflected by chlorophyll, they can instantly assess the health of a nation's crops, predicting a potential famine or economic crisis. By filtering for the unique spectral signature of disturbed Earth, they can locate the construction of a hidden missile silo. These filters are the tools that allow us to see the unseen. What appears as a uniform field can, under a specific wavelength, reveal the buried foundations of an ancient city. What looks like an empty patch of desert can blaze with detail when viewed in the infrared. In the world of intelligence, you never trust the primary image. The truth is not in the picture we see, but in the layers of light that are hidden within it,
a story waiting to be revealed by the correct filter, the correct analytical prism. In the final analysis, after all our strategies, our technologies, and our conflicts, we are all subject to a single, overriding imperative. It is the same silent command that guides the humble plant, the instinct to turn toward the light.
This process, phototropism, is not a conscious choice. It is a fundamental law of life, a cellular-level recognition that light is energy, and energy is survival. This simple, graceful turning is the foundation of the most important chemical reaction on our planet, a process of such elegant efficiency that it dwarfs all of humanity's technological achievements combined. This is photosynthesis. It is the quiet, planetary-scale alchemy that turns pure sunlight into the energy that fuels our world. Within every green leaf, a microscopic factory captures photons and uses their energy to break apart water and combine carbon dioxide into sugars, the primary fuel for nearly every food chain on Earth. The energy you are using to think, to move, to live at this very moment can be traced back through the food you ate to a plant that captured it from the sun. Our entire civilization is solar-powered, but we have been drawing from an ancient and finite battery. The fossil fuels that power our industries and armies, the coal, the oil, the natural gas, are nothing more than millions of years of buried sunlight, the stored energy of ancient photosynthesis. Our global economy, our political power structures, our military might, all of it is built upon a foundation of ancient light. This is the ultimate strategic reality. The control of energy is the control of nations, and for centuries that has meant controlling the geographic locations where this ancient sunlight is buried. But the sun has not stopped shining. The sheer scale of the energy that our star provides is almost impossible to comprehend. In a single hour, the sun floods the Earth's surface with more energy than all of humanity uses in an entire year.
Our most destructive wars, our most ambitious industrial projects, the entire combined output of our global civilization are but a whisper compared to the silent, continuous torrent of power that falls freely on every rooftop, every ocean, and every leaf. This humbling reality is now driving the next great geopolitical shift. The transition to renewable energy is not just an environmental goal, it is a strategic realignment, a move away from the finite, geographically concentrated energy of the past toward the diffuse, universally available energy of the present. The nation that perfects the art of capturing this light through advanced solar cells and new forms of energy storage will achieve a level of energy independence that was previously unimaginable. In the vacuum of space, this principle is taken to its logical extreme. Solar sails, vast reflective sheets designed to ride on the gentle but relentless pressure of sunlight itself, represent more than just a new form of propulsion. They are a philosophical statement. A solar sail requires no fuel, produces no exhaust, and can, in theory, accelerate for as long as the sun shines. It is a technology of quiet patience and infinite possibility, a way of moving through the cosmos on a breath of pure light. This is the ultimate duality of our relationship with this fundamental force. Down here on Earth, we have turned light into a weapon, a tool of surveillance, a medium for control. We use it to guide missiles, to blind our enemies, and to manipulate perception. But out there, in the vast, silent dark, it offers a different path. It is our only means of escape, a cosmic wind that could one day carry us to other worlds. From the beginning, light has been both the battlefield and the prize, the message and the medium.
Light is not just a part of our world, it is the world. It is the clock that sets our rhythms, the the energy that fuels our bodies, the information that feeds our minds, and the ultimate unbreakable law that governs our reality. Our story, from its first spark to its final quiet fade, is written in light.